NASA's next-generational telescope, the Nancy Grace Roman Space Telescope, is set to make its counterparts, the James Webb and the Hubble telescope, look like complete amateurs. Okay, maybe not amateurs, but it will certainly show off the universe in a way we've never seen before. That being said, the new telescope also comes with a potential unsettling discovery: how the universe will end. Planned to launch in 2027, the Roman Space Telescope will set off with the aim of understanding more about the dark matter and dark energy that haunts our universe, whilst also assisting in NASA's goals to locate and understand more about Earth-like planets in both near and distant galaxies. It is hoped that the telescope will help answer the fundamental question of how many planetary systems like ours exist, and do any of them harbor life? The Roman Space Telescope will use its coronagraph instrument to block out the blinding light from distant stars, revealing the hidden planets that lie in orbit of them. This process makes objects more than 1 billion times fainter than its star visible. This results in the ability to investigate individual planets and star systems similar to our own for the first time. It will target rocky planets within a region where liquid water could exist, and is expected to locate 2,500 planets. It will be able to team up with the STScl, which is an active satellite mission, to help with the aim of finding habitable exoplanets. We will also see it work together with the Hubble and Webb telescope to identify the characteristics of these exoplanets, in the hope to make further groundbreaking discoveries. The Roman Space Telescope is similar to Hubble, in that it will have the same depth and clarity of view as Hubble's imaging. But the Roman will capture an area 100 times larger. This is due to its spectacular wide-field instrument. The wide-field instrument contains 18 detectors, which allows it to capture 300 million pixel images of large areas of the sky. Thanks to the phenomenal technological advances, the wide-field instrument will be capable of detecting infrared light from farther than any previous telescope. As a result of this, some of the biggest mysteries of the cosmos can be solved, including how the universe looked in its early years, and how it has expanded over time into what it is today. Originally, scientists measured the rate of the expansion of the universe by using ground-based telescopes to study supernova explosions. Then, in 1998, the Hubble telescope observed more distant supernovas, which in turn led scientists to understand that the universe expanded at a much slower rate in the past than it does today. For a long time, we thought the expansion of the universe was slowing down. In actual fact, it's speeding up. The cause of this? Dark energy. This is what scientists believe makes up most of the cosmos. But what is it? Well, one of the Roman telescope's main objectives is to answer that question, because so far nobody has a direct understanding of what it actually is. What we do know is that it is a strong pressure, stretching the universe at an accelerating rate. And that's about all we know about this cosmic mystery. Without a deeper understanding of dark energy, we cannot piece together the beginning and the future of our evolving universe. This is where the Roman Space Telescope comes into play. With its ability to capture multiple galaxies in a single photo, the telescope will map out the exact positions and distances of millions of different galaxies, which will allow astronomers to understand how the placement of galaxies has changed. This will reveal how dark energy has affected the universe's expansion over time, and how it may further expand it in the future. Worryingly, NASA believes that if the dark energy continues to accelerate the universe's expansion, we may experience what some refer to as a big rip. This is where dark energy becomes so empowering over other forces like gravity that everything that is currently bound together, including planets and galaxies, would completely break apart. As daunting as it is, it's important that we explore dark energy, as it may show us a glimpse into the universe's evolution and our potential fate. Moving on to more exciting features, let's take a look at some of the phenomenal capabilities we can expect to see with the Roman telescope. This is a video of the Eagle Nebula, firstly pictured by Hubble. As we zoom out, we see the effect of the wide field instrument, showing a full field of view of the area. Even with the wider field of view, we can see the stunning resolution remains to the same level of the lower pixeled image captured by the Hubble. Here we see another image taken by the Hubble, this time of the galaxy cluster Abell 426. We compare it again to the capabilities of the Roman Space Telescope, where we see an area about 100 times larger than the image taken by the Hubble. The telescope will orbit at L2, an area in space around 1 million miles away from Earth, containing stable conditions for a satellite to remain operational with minimal effort. NASA are extremely optimistic about what this telescope will be capable of, and we for sure can't wait to see the incredible results it produces. For now, we will continue to observe the spectacular images captured by the James Webb Telescope, and we will count down the days before we get to see what is truly possible when the James Webb, Hubble, and the Nancy Grace Roman Space Telescope team up. Thanks for watching the video. Please subscribe to the channel if you learned something valuable, and take a look at another one of our videos.